Math Crash Course, Day 4, Part 2. We've got a new concept we got to go over. One last concept that's tested on the TSI. Not a ton, but it's tested. I want you to be aware of it. It's called functions. And this is a function question here, Jackson. I want you to read it here. Question number 1. Right? A lot of students see it and they say it's g times x. That's not what it is. It's called function notation. That's a function. You might see it sometimes p and then in parentheses x or f and then something and then x in parentheses. So that's read g of x is equal to, and then that's 3 times x in parentheses. Or sorry, 3 times parentheses x plus 8. Right?
Yeah.
Okay. Undo. Okay. What that means is, where there was an x, now there's a 3. Okay?
Yeah.
So all f of 3 is it means 2 times not x, where there was an x, now there's a 3. 2 times 3 plus 1. So I would say f of 3 equals what?
Okay.
F of 3 equals what?
Oh, I thought,
What's that equal to?
F3?
Mm-hmm. F of 3 equals?
2.
2 times
2,
3.
2 times 3 plus 1.
Yeah. Which is what?
6 plus 7.
Yep.
7.
F of 3 equals 7. Does that make sense?
Yes.
Okay. Now I know it's a little bit confusing here because we've been working with parentheses, and parentheses has meant multiplication, not with function notation. Right? And you know you're working with functions because they'll say the function g, the function f, the function p. They'll let you know it's a function. Okay? It's like an equation. Almost the exact same. Okay. They'll let you know. So we know we're not doing multiplication. We are doing multiplication right here. Does that make some sense?
Yes.
Okay. Okay. As long if there's an f or a g or a p, you're probably not talking about multiplying variables f, p, and g. And again, they'll always say this is a function. The function g, the function f, the function p. Okay. Okay. Let's do it again. Let's do the same function. Okay. I'm just picking, again, I made one up that's a little bit easier than the one in the question just to make it really clear how functions work. Let's find f of 4. Okay? F of 4. What do we do for f of 4? It's the same thing. Where there was an x, now there's a 4. So what do we do, Jackson? You tell me. Where there was an x.
Let's replace the x with the 4.
Exactly.
So
exactly.
Add 2x, 2, 4.
2 times 4.
That's 1.
Exactly. So f of 4 equals what?
F of 4 equals 8 plus 1, 9.
9. Absolutely. F of 4 equals 9. Okay. Another way to explain this is in terms of inputs and outputs. Okay. A function is sometimes described like a calculation machine, a calculating machine. Okay. When I plug in a 4 into that function, all right, I plug in a 4 for x. I get
0 plus 1.
Yeah.
So 1.
Yeah. F of 0 equals 1. Exactly. Right? Inputs and outputs. When x is 0, when I get an input of 0, I get an output of 1. Right? Which is why function notation is useful. I remember as a student, in fact, I remember being like, what was wrong with y? Why did we go to f of x and g of x? I liked y. I got y. That made sense to me. Why, why do we try to see f of x and g of x? Right? In fact, I tell students, like, f of x is just fancy y. Right? But the cool thing about function notation is, like, it can tell you the relation between your x and y values. When x is 0, your y value, or your output, is 1. In fact, I could graph that point on an xy axis, where x is 0, 0, 1. When x is 0, your output, really your y value, basically. F of x and y are synonymous, right? On like an xy axis, this is always the x-axis. But this right here, this is, the y-axis, but it's also can be described as the f of x-axis. F of x and y are the same. In fact, I've got a section here on the rules for math. Let's go to the rules for math real quick. Rules for TSI math. Functions, basic concept F. Go ahead and read that for me, please.
Okay. Understand x as the input. F of x as the input.
As the output.
Also understand f of x as fancy y.
Yeah. Yeah. So, like, Let's go back to the f of x being fancy y thing. If I were going to graph this function right here, that would graph the exact same way as y equals, that's an ugly y, let me fix that. Y equals 2 of x, or sorry, 2 times x plus 1. It's the exact same graph. Exact same. Right?
Yeah.
f of x is basically fancy y. Okay. But it helps you describe the output or the y value in terms of the input. Right? So like, times x plus 8, what is g of 12? It's the exact same thing we've been doing. What do we do? I think you just said it.
We just put 12 in.
That's it.
So,
for what? 12 in for what?
So we're just gonna put 12 in. So 3.
Yeah.
X. 3 times 12.
Yeah. Yeah, but in parentheses, right? That's better. Yeah, I would do. Let's I want to make it real clear for anybody watching the recording here. I would plug it in like this, and just you can put the 12 in parentheses, but then you got double parentheses. You can do that. I would just do that. Multiplication. I think that would be helpful. I'll add that. All right, so 12 plus 8 is what? It's just what's your output or your y value or your g of x value, or the same thing. It's all the same. What's your output when x is 12? That's all it's saying. That's all it's saying. Okay. Questions about that, Jackson?
No.
Good.
I see what's going on.
Good. Good. Functions are not bad, and like this